let's add up washers. Oh, you did the beep?
Yeah.
Thank you. Let's add up washers. Well, now, instead of adding up discs or squares or triangles, we're going to add up washers. That is cylinders with holes in them. So let's go ahead and actually see what happens. Rather than me just giving you the formula, let's actually experience a situation. Okay, I've got a region bounded by y equals x squared, y equals rad x is revolved about the x-axis. Get the volume. Okay. So let's go for it. And I'm thinking, okay, this is easy. I'm feeling pretty comfortable with this stuff. Alrighty. So here's 0, here's 1, here's 1. Okay. Here's my parabola, y equals x squared. Here comes my radical, y equals rad x. Okay, this is y equals rad x. And I'm going to revolve this about the x-axis so that it ends up looking like this. Okay. I'll give it some three-dimensional look. Do you see now? This isn't a solid. What would you call this thing? What does it more resemble in your day-to-day life? Yeah, a bowl. A weird bowl that comes together. What did you say?
I said a flower.
A flower?
It looks
Okay,
like
good.
the thing in Iron Man's chest.
Iron Man's chest. Good. Good. Alrighty. Well, I'll tell you, I'm going to make cross sections perpendicular to the x-axis, and here's what my cross sections look like. And I'm actually going to shade in this back part here and shade in the front part here. All right. And again, you know, a good drawing is better than no drawing at all. I mean, a bad drawing is better than no drawing. Okay, so do you get a sense that each cut perpendicular to the x-axis is going to get you a washer? It's going to get you a cylinder with a hole in it? So at this point, we've got to figure out what the volume of a washer is. Alrighty? And let's do it right here. Volume of a washer. Okay? Let's say I have a cylinder with a hole in it. And let's say the radius of the hole is small r, and the radius of the outside, what we call the outer radius, is big R. And let's say that this height here is h. How am I going to get the volume of a washer? How do I get the volume of a cylinder with a hole in it?
Subtract big and small.
Okay, good. Subtract the small from the big minus the small, right? You just get the volume of the solid cylinder and then subtract off the hole. You guys okay with that? So this volume is going to be pi big R squared h minus pi little r squared h. Now, our textbook is not satisfied with that. Our textbook likes to factor, and so our textbook would factor out the pi and the h and leave us with big R squared minus little r squared. Now, ordinarily, my h is dx or dy, so that guy gets put on the right. So you end up with pi times big R squared minus little r squared times h, or pi times big R squared minus little r squared times dx or dy. So this ends up being, oh, and this is the differential volume. I should say, well, that's the volume of a washer, but it's the differential volume if it's one little washer, wafer. So I want you to see that all we did was do what Omar said. We just took the entire cylinder and subtracted off the hole, but our textbook simplifies it to look like this. But if you ever forget the equation, you can always just get it back. Just do the entire cylinder minus the hole. So anyway, looking here, looking at this representative cylinder, or representative washer, I've got this radius, which I'll call R, and I've got this radius here, which I'll call big R, okay? You tell me, what is small r? Hope you're seeing it's the y coordinate on this graph.
Yeah.
And what is the y coordinate on this graph?
X squared.
Yeah, x squared. Look at big R. Big R is going to be the y coordinate on this graph. And what do we call the y coordinate on that graph? Yeah, rad x. Okay, so now that I got small r and big R, it's the y coordinate on this graph and the y coordinate on that graph, I can get an expression for my differential volume. Pi times big R squared minus little r squared dx. I'm in dx land because the thickness of these washers is dx. And so I get pi times radical x squared minus x squared squared. Right? Small r is x squared, big R is rad x. And now I can get an expression for the volume itself. Volume is going to be the integral of pi times x minus x to the fourth dx. And since I'm in dx land, I'll integrate from 0 to 1, because that's what this is, that's 1. And so I'll go 0 to 1, and then I'll do punchy and get my answer. Any questions or issues on this process? Okay, then it's your turn. Okay. Region bounded by y equals x squared plus 2, x equals 0, x equals 2, and y equals 1. So I've just given you a region bounded on all four sides. It turns out to be above by y equals x squared plus 2, to the left y equals 0, to the right by x equals 2, and below by y equals 1 is revolved about the x-axis. Get the volume. Hey, good luck. Draw a picture, make your little washers, label your washers, get small r and big R, and then let it rip. Keep working, but you should end up with that region being the region that gets revolved about the x-axis. guys get this. Oh, look at that, Omar, very nice. Going bigger is better. Right, oh, that's just beautiful. Oh, it was really ugly. Yeah. Just make sure that inner circle is going from -1 to 1. Where's your, can't really make anything out of it. Ooh, very nice. Cool. People make it drawings. Oh, very nice. Very nice. Some of them are nice, some of them are ugly, but guess what? They're all beautiful. Just like my children. That's beautiful. Good. Ooh, looking good. Now you're ready to get an expression, get small r, get big R, and do the thing. Hey, once you got your drawing, get small r, get big R, and then do pi big R squared minus little r squared times dx. That's very nice, by the way. We're still working on it. I think that's very nice, Brandon. Yeah, that's beautiful. Yeah, so small r is going to be, tell me what small r. Yeah, dx, each of the thickness is dx. Okay, keep it. Oh, look at you. Okay. Now, I'd like to intervene for a second. There's a reason I like to draw multiple washers. Number one, because it looks really pretty. But also, number two, it does give me insights into what big R and little r are. So for example, look at little r. What do you notice about the little r for every washer that I make? Yeah, it's 1, right? That's not a variable, that's not changing. Little r is 1 for this guy. You see what I mean? So, and that maybe I wouldn't have realized that if I hadn't drawn multiple washers, where I can see, hey, the inner radius is the same for every washer I choose. But big R is a different story. Big R is changing. It can be smaller or bigger or bigger or biggest, you know? So I know big R is going to have variables, and big R is going to be, as you see, the y coordinate of this graph. So big R is going to be x squared plus 2. Now, one thing I want to make clear to you now, even though I'm going to emphasize it more later, your radii are always measured relative to the axis of rotation. Your radii are always measured relative to whatever line you happen to be revolving your area about. You know? So in this case, I'm revolving my areas about the x-axis, so all of my radii are going to be measured relative to the x-axis. And that's going to become a more important issue like tomorrow. But alrighty, well, hey, let's go for it. My differential volume is going to be pi times big R squared minus little r squared, little r squared. Oh, so my son shows me a video by a guy named Lil Pump, and it's called Gucci Gang. It's just absurd. Have you guys seen that?
No.
Oh, you should see it. It's just hilarious. It's like, you almost, I mean, is this serious? Is this, you know, Gucci Gang, Gucci Gang, Gucci Gang, Gucci Gang, Gucci Gang. It's just ridiculous. It's like something a child would do, but it's really popular. Okay, so I got x squared plus 2 squared minus 1 dx, and hopefully you see that I'm going to have to integrate along the x-axis from 0 to 2. And there you go. Did anyone get that answer? Oh, good for you guys. Yeah, many people. Good. Just once you get big R and little r, you're in like Flint, you know? Let me see what else I got from you guys. I've got another one. But I want to do one about the y-axis. Here, I'm just going to show you one. I'm going to show you one, and then I'm going to do one about the y-axis. I kind of want to show you all the different possibilities. Here, we had one where the inner radius was a constant, and the outer radius was changing.
Is there one with an outer radius that's constant?
Yes, there is, and that's what I'm going to show you right now. Good for you, Andrew. Yeah. So here, and like I said, I'm I'm just gonna zoom through this one, since we've only got 7 minutes left. Here's example number 3. I got the region bounded by y equals rad x, y equals 3, x equals 0, x equals 4, revolved about x-axis. Well, okay, let's go ahead and draw this thing. Here's 1, 2, 3, 4. And here's 1, 2. And I got so here's y equals rad x, but the region is bounded by y equals 3, y equals 3, x equals 0, and x equals 4. So do you see the region I'm revolving now is this region here? Okay. So when I revolve this region about the x-axis, I'm going to have the other guy looking like this. So let me just three-dimensionalize this guy. Okay, so I'm going to draw a representative washer. Oh, how I love making 3D drawings. Okay, so I hope you see now my big R is constant. You see what I mean? My small r is changing. Small r can be small, bigger, biggest, but big R is always 3. So looking at this drawing, big R equals 3. Small r equals the y coordinate of this graph, which is rad x. And so my volume, I'll just cut to the chase. I'm integrating from 0 to 4, and it's going to be pi times big R squared minus little r squared times dx, you see? So like I said, so you can't know a priori whether big R is going to be a constant or a variable, or little r is going to be a constant or variable. The only way you know for sure is to graph the stupid thing. Make a picture and look at the picture and make your determination based on the picture. That's all you've got on these problems. But if you do a good picture, your chances of getting a right answer are extremely high.
Would it be okay if we use like a calculator to graph them, like all around the AP test?
Yeah, you do it however you're comfortable. You just need to visually see what's going on, Okay, hey, I gotta do one more with you guys about the y-axis. And, I think most of you will be able to figure this out okay. But what if I had y equals x squared, y equals 0, x equals 2 about the y-axis? So I have my region bounded by those graphs. Okay, here's y equals x squared, here's y equals 0, and here's x equals 2. So are you okay that this is my region? And I'm going to revolve it about the y-axis. So it ends up looking like this. So again, it's another bold. Let's get some representative washers here. So Andrew, you've never seen a Little Pump video, huh?
No.
You should. It's really instructive.
Oh.
It'll tell you why American culture is dying.
I thought it was still going.
That's a good question. American culture. Okay. Well, first of all, it's better to make all your measurements from the original area and not like the shadow region, not the reflected region. But I hope you see that this thickness isn't dx. This thickness is dy now. So I know I'm going to be in dy land. Alrighty. Next, I hope you see that this small r is the x-coordinate of this graph. You see that? He's going to fix my door so kids don't break their arms from it anymore. You guys okay? That the distance from there to there, I'm going to have to call it x. It's the x-coordinate of this graph. Well, this graph is y equals x squared, which means rad y equals x. So this guy ends up being rad y. This is the x-coordinate. And you tell me, what's big R going to be? Yeah, hopefully you're getting 2. Big R is 2. Every washer I make is going to be 2. So now here, just a second, we're almost done. So my differential volume is going to be pi times 2 squared minus rad y squared dy. I had to express it as rad y because I'm in dy land. I can't have an x there. And so my volume is going to be the integral of pi times 4 minus y dy. And I hope you see that because I'm in dy land, I'm going to have to go from 0 to y, 0 to 4. Sorry about the lateness of this. So anyway, so you'll get a chance tonight to do some problems. Most of them I think are pretty easy. 3, 4, 5, 6, 7, 8, 9. 9 of these problems. I don't know. We'll see how long it takes you.